right, good morning, everybody. I think this is the first talk of the day post-keynote, so might as well get started on time and try to keep the schedule going. I am Rob Zuber, CTO of CircleCI. Thanks for joining. And I want to talk to you today about abstracting heavy lifting. So at CircleCI, we're very focused on developer productivity, helping engineering teams do the job that they should be focused on doing and taking away a lot of what we call undifferentiated heavy lifting and a lot of the work that really you can leave to someone else. And so we think about that a lot in terms of the product that we deliver, but we also think about that in terms of how we build our own stuff. And so that's more what I want to focus on here. But in order to understand the things that I'm going to be talking about, you need to know a little bit about CircleCI and sort of how we got to where we are today. So as a company, we do continuous integration, continuous delivery, or continuous deployment. We offer that in the cloud, where we manage all of your compute for you and execute your jobs on your behalf. And we also have a server offering where you can take our product and manage it and run it yourself. In our cloud environment, we support about 300,000 developers across well over 12 million builds a month at this point, and a little over 25,000 organizations. But it wasn't always this way. So if we go back a little bit, CircleCI was founded in 2011 and launched the product in the beginning of 2012. And I always like to start with architecture diagrams that look a little bit like this, because this is basically what we had built, right? It's a startup. We're not really sure what it is we're trying to achieve, and if you're a new company or launching a new product, this is usually what your product looks like, right? It's very simple, it's easy to reason about, and it's easy to manage in your production environment. And we only had one offering. We were offering this service in the cloud, again, running your compute on your behalf, executing jobs on your behalf so that you could focus on building your business. Fast forward to about 2015, and we decided to also offer a server product. And so the difference there is you would take our application and run it on your own premise, or on your own premises behind your firewall, in basically running the thing that we are running in the cloud. And again, the architecture was pretty straightforward, right? We had a pretty simple monolith, but we did have some additional services in the sense that we have data stores. We were using an outsourced WebSocket provider, so we needed something to replace that within our application, et cetera. And so we had a few small containers that we needed to coordinate, and then we had the specifics of on-prem hosting or an on-prem offering. So license management, upgrades, things that we do behind the scenes in a cloud offering that we have to provide to our customers who are going to manage this themselves. And so we went in search of a solution, and honestly, with the sense that, hey, this is a thing we need to get to market. Is there a tool that we can use that will help us get this to market, and then we can replace it later with something that we would build, right? License management doesn't seem that hard, but that's not the thing we want to focus on right now, et cetera. So we started off with a tool called Replicated. They're actually here at the show. Great tool. If you want to go chat with them, I would recommend you go. And if on-prem is a thing you're trying to solve, great folks to talk to. And they brought most of these pieces that we were missing. So the coordination of some jobs within our environment, along with license management, upgrades, some phone home around who our customers were and how they were using the product, et cetera. And so that was great. It got us into the market and allowed us to deliver this on-prem solution. Fast forward another year, and suddenly our product looks like this, right? Our engineering team is scaling, our service is scaling, and instead of just having a simple monolith, now we have a large collection of services, all of which talk to each other. I obviously didn't draw all the network interactions between them here, but it's a very different view of a product. And 5 monoliths across the bottom, because not only do we have all these services, we still have a monolith, and we've taken the monolith and configured it in a bunch of different ways so it does different jobs in our production environment. And so this is now a problem that we need to handle and deploy across a very large piece of cloud infrastructure, which is very different from the problem of giving it to a small customer and letting them run it themselves. So now we're in search of a solution to that problem. And it's also a little bit later and technology is developing. And so we end up with Kubernetes. And this makes a lot of sense for the cloud environment in terms of what we want to deploy, how we want to deploy it, how we want to manage it, and seems like a really excellent solution. But now we've got two problems, right? We have the exact same set of software that we're trying to deliver in two totally different ways. And believe it or not, this leads to some challenges. In fact, because we have a distributed system, we really have more like n-squared problems. So every single thing that we do inside of our product, inside of our environment, we have to solve in two different ways. How we manage communication, how we manage configuration, and it's starting to lead to a set of challenges for us in terms of delivery, which is, our teams are deploying things into the cloud. We're a CI and CD company, so we do continuous deployment. We are using configuration sort of tailored for Kubernetes as we push things out into the cloud environment. And then we go to package up a release of our server product, and it turns out that something we've done in terms of our product to get into cloud doesn't work properly in the server environment because we're using a completely different scheduler with different configuration mechanisms, et cetera, et cetera. So now we need to find a way to get out of this situation. So if you're feeling as anxious about this problem as I am, I figured like a little cute slide would maybe make you feel a little more relaxed. But one of the things, one of the areas that we go to solve a lot of our problems, especially when we're a CI and CD company and think about these things, is DevOps, right? Like how does our framing of this thinking help us get to a better place? And so this is really meant to be developers and operators working together in the new world of DevOps. But I think it's worth looking back a little bit at how we got here from a DevOps perspective and what that tells us about where we're going next. And specifically, if we go back to the beginning as really a shift in culture, I don't know how many of you were there back in these days, but we had two completely different organizations inside of a company trying to get work done. You've got developers who are working specifically in their dev environments, and you've got operators who are sort of holding the keys to the kingdom in production and in between what I often refer to as the chasm of despair. Like the notion that you were actually going to get something from development into production was everybody's nightmare. Developers didn't want to have to deal with it. Operators didn't want developers changing their environment. I mean, we all remember what that looked like, right? So we started to have a shift in culture, and that shift started with automation, right? If we have some good tooling that allows developers to move things from their development environment into production, then maybe we can solve some of the challenges we're facing, right? So we get to smaller increments, we deliver those with a lower risk profile, and everyone's a little bit happier about the kinds of changes that we're making in production and confident that we can undo those changes or fix them quickly as we run into them. But now I think we're a little bit further along this path, and in particular, we've sort of shifted from developers and operators still being kind of separate but having tooling to work together into a world where all of us are working in the same way, right? So we have application developers who are responsible for delivering our product code out to a production environment, and then we basically have, in a world of SRE, infrastructure developers who are following the exact same processes, right? We're treating our infrastructure as code, we're using automation to validate it and get it out into production, and so we're just working at different levels of the stack versus working on different sort of verticals of the environment. And so this has, I think, been really good for all of us because it's an opportunity to really refine and learn from each other. So this photo is it's a piece of Japanese humor that I love. So our GM of Japan was in town and brought these T-shirts. This is myself and our CEO, and his T-shirt says, I can't even read it, so you probably can't. I completely understand CircleCI, and my T-shirt says, I can do CircleCI a little. And with a great sense of irony, the point is, the more that you learn about something, the more you realize how little you actually know. And I think this crossover in how we work is a great opportunity for everybody, for operators, to learn from software developers some of the things that have really been the domain of how we design and build software, and for software developers to learn from formerly operators what's classically been the domain of running production operations. So going back to that previous view, you have developers pushing stuff out into production and carrying the pager and thinking about resilience and recognizing that I also don't want to get up at 3 o'clock in the morning. And then from an operator perspective, thinking about, and now not operator, but maybe an infrastructure engineer, thinking about the things that we've spent our time thinking about in the software development world in terms of how to be productive and build effectively. So here are some things that we've learned and how they apply to this pathway of getting us into a better place from an overall operational perspective. First, you want to understand your customer. I mean, ultimately, at the end of the day, you're building for a customer, and if you're very clear about who your customer is and what they need, then you can make sure that you're building the right things. And building the right things saves a lot of time. Focus on your core competencies, right? Don't build the things that are not really differentiating you as a business. Use abstractions to isolate change, and use abstractions to reduce complexity. So starting with the first one, understanding your customer. So this is Maya, Jenny, Dante, and Diego. And they're 4 personas that we use internally at CircleCI. And this is really helpful for us. They represent not just the developer who is using our product to do CI and CD. They represent the operator within a company that's managing our platform, business decision makers, and engineering management, everybody who would participate in the use of our platform, so that as we think about what we're trying to deliver, we're very clear about the person for whom we're trying to deliver it and what their needs are as a customer. And this is great, but your personas are only as good as they are correct. So if you misread your customer, then you're going to be building to the wrong set of needs. So as we looked at this challenge of we have one way of deploying for server, another way of deploying for cloud, we had to sit down and reflect on who our CircleCI server customer really is. And this is the operator of the product. So first of all, if you are taking our cloud offering and running it yourself, you're probably a very sophisticated development shop. If you don't think that you can make use of our operating this thing for you, then you probably have a team of some significant size with the ability to manage a reasonably sophisticated product. And so the notion that a sort of one-click install or simplicity is going to be the most important thing for you is maybe not correct. Second, you're probably experienced with Kubernetes. I mean, at this point in 2018, we're at KubeCon with 8,000 other attendees. Like, Kubernetes is out there, right? There is a lot of understanding, there's a lot of resources in order to be able to manage something like this. And so giving someone something that's completely prepackaged and different may or may not be the right outcome for us. Probably not at this point. Live upgrades are more valuable than one-click upgrades. So what that means is a company that's running our server install is, again, a sophisticated shop. They probably have developers all over the world, and they probably have someone working at any hour of any day. And so it's more important to them to be able to do what we do in our cloud environment, which is like live, no downtime upgrades, rolling upgrades of various components, than it is to be able to just click a single button and have everything magically work and come back up. But that requires some kind of notification, downtime, maintenance window, et cetera. And finally, they generally operate like a multi-tenant cloud. So CircleCI was designed and built so that we could operate the service and many, many different companies and different customers could use the service to get their work done. And this is actually what very large software organizations look like. There's a team that is central, creating leverage and creating efficiency for their engineers, and the engineers need control of their own ability to work. So that central team can't be managing changes to configuration, updates to the server, et cetera, just for the needs of one specific development team. So they really operate in the exact same way that we operate, which is, again, like a multi-tenant cloud. And so providing them a system that looks and operates more like our actual cloud system is the best fit. So now we have a much clearer picture of our customer. Next, we want to make sure that we're focusing on our core competencies and the things that really drive us as a business. So we spent a lot of time this year thinking about domain-driven design. I don't know if anybody here has read this book or books like it or thought about domain-driven design. I would highly recommend it. It's really about, and this is the original book by Eric Evans, who sort of drove this thinking, but there's a number of other authors who have written similar books. And it's really about understanding your domain overall and recognizing that large software systems are complex. It's difficult to reason about the entire thing at once, and therefore you need to break it down into subdomains. And one of the most important pieces of that exercise is understand which of those subdomains are really critical to you and are core to what you're offering as a business, and which are not. They're supporting or generic. So this is a bit of a map of what that looks like for us at CircleCI. I described already, we do continuous integration, continuous deployment, and that really breaks down for us into two core domains. One is workflow coordination, which is an overall graph of the jobs that you want to run and how they are interrelated, what the dependencies are such that when one completes successfully, another should run, or if one fails, what the outcome should be overall for the workflow. And then the other is job execution, which is really finding capacity in the system, configuring it correctly, and executing the actual steps of work that you want us to execute in order to validate and build your software or to deploy it into your production environment. And then all these things around the edges, like plans and payments, I think is a great example, are generic in the sense that no one comes to CircleCI because they're super excited about how we charge their credit card. They might be annoyed if the form doesn't work properly or something like that, but we're not changing the world of CI and CD with better payment forms or a different way of doing discounting or something like that. These are generic systems and they're solved problems. There are people out there who have built fantastic billing and payment systems and plan systems, and we should just leverage those. And this is actually a very liberating process to go through, by the way, because recognizing that you should just take something off the shelf is a really great place to be. So what's interesting about this is that you can actually go another level down. So we've called out generic domains and core domains for us, but within those, you'll see similar patterns. So within job execution, which I just said is absolutely core to our business, you'll find that there are things that we do that are very specific to us, like the construction of the environment and signaling the inputs and outputs, and the things that are, we basically provide a DSL over compute to allow you to do CI and CD. Whereas resource availability, making sure there's enough capacity online to meet demand at any given time of the day, is a solved problem, right? It's an auto-scaling group. And task scheduling, I mean, we're at KubeCon. There are people that have figured out how to do task scheduling very effectively, and it's not something that we should be doing. In fact, we did it for a while, and it was a disaster. So there are tools out there that we can use. If you go to the other end, take something that I had called out as pretty generic previously, which is the operation of our environment itself. We have some generic pieces of that, which is container orchestration. Again, Kubernetes is a great tool for that. Observability. Like, I'm not going to rewrite stats-D or Prometheus or whatever to get metrics out of the system. There's a lot of great tools out there for logging. These are not things that I should be building. They're just things that I need to have available so someone can operate the system effectively. But the upgrade management and how that works is very core to how people use our system and how they perceive it. And in a world where we had sort of packaged this up using an off-the-shelf tool, we lost control of upgrades. So there was only one pathway to do an upgrade, and that upgrade path was not appropriate for the majority of the customers that were now becoming primary customers of the system. Okay. So another key thing that we've learned as software developers, or hopefully learned, continue to learn, but I think we need to apply to how we think about systems, is isolating change through abstractions. And I think that what happens when we go and evaluate technology, and one of the reasons that we're always so stressed out when we're evaluating technology and trying to decide what to do, is we go all in. Like, once we've decided that we are going to use a specific tool, we bake the assumption of that tool into our entire platform, right? We reference that in many, many different parts of our application to a point where we can't get back out of it. And so if you spend time thinking about software design, you've probably in recent years come across a picture that looks like this. There's a couple names for it: hexagonal architecture, ports and adapters. And it's really about changing the way that we isolate our external systems from our software. And the key point on here is that you have domain logic, and that domain logic should have no understanding of the inputs and outputs to your domain. And specifically, if you look at the driving adapters on the left or the driven adapters, you have an HTTP API, let's say. And maybe today you're using REST, and tomorrow you might decide to use GraphQL. The business logic of your domain should not change as a result of that. It should be completely isolated from it. And if you look to the right, I think what's really interesting is we've thought we were doing the right thing around isolating databases, for example. But ODBC and JDBC are not abstractions. They're libraries that give you simpler access, but you're still tied in to the notion that you're using a relational database. Even an ORM at that point is not an abstraction. The abstraction is the notion that I have something to store and I don't care how it gets stored. And when I do that, when Cassandra becomes the right solution, I don't have to go change my assumptions all the way through my code base. So what does this look like when I'm trying to insulate myself from the cloud? First of all, when I'm moving across multiple cloud providers, I can use well-known established interfaces. Right? It doesn't matter to me if I'm using Postgres in RDS, or I'm deploying it myself, or I'm using a Postgres interface provided to me in GCP. It's still Postgres. And Kubernetes is the same thing. So for us, we run Kubernetes ourselves with our own install. We're actually looking at moving that to one of the cloud provider installs so we can do less management. But the interface for us is the same. So that's one option. But not everything works like that. The blob stores, for example, in different cloud environments look different. But there are tons of libraries out there. I can go pull JClouds off the shelf or GoCloud or whatever library is available to me in the language that I'm developing in so that I can be completely insulated from that. But if you go back to the previous notion, you still want to put your own adapters across all of these layers so that when you say, you know what, we're not going to use Postgres anymore, we're going to use Mongo because we have this specific need and we're going to move something into there, or we need to do our scaling slightly differently, or whatever, I've isolated myself again from those choices and created the opportunity to make change without significant impact. And just as a reminder, this is basically what that would look like, but now we're thinking about it from an infrastructure perspective, not so much from a code and cloud or from a code and application perspective. And then finally, we want to use abstractions to reduce our complexity. So I've been reading this book lately by John Ousterhout. I'm not actually sure how to pronounce his name. A Philosophy of Software Design. And it's a very good, thought-provoking book, I would say. I don't necessarily agree with every single point that he makes, but that's good. That's how we should consume our books. But the emphasis on complexity throughout his writing is extremely valuable, because as we look at the software that we build, his point is the greatest limitation that we have is our ability to understand our own systems. So in software, if you think about any other engineering discipline, we are about as limitless as it gets, right? I have an editor, and I have some ideas, and I can just build and build and build, right? This is how we end up building everything ourselves, honestly, because we feel unconstrained. If I'm trying to build a bridge, I have a lot of constraints. But if I'm writing software, the only thing that's really holding me back is my ability to keep managing the complexity of that software. And so, going back to our design problem, we were in this space where our application went all the way down to the cloud provider or the metal, depending on how you're deploying it. Meaning, we've taken an off-the-shelf component, which is, again, replicated this third-party tool that manages a lot of our orchestration stuff, and we've made that part of our system. Because if I give you a package, and that package starts with replicated, and you don't know anything about that, then I am now supporting this third-party tool plus everything that I've built, right? And so the interface feels very simple, again, going back to who our customer is, we thought that the best possible interface to give you was one that was very light, had this sort of one-click installer, one-click upgrade model, and for you, as a customer of ours, felt very simple. But we, in terms of managing our platform, have pulled in all of the complexity of that. And so by moving to Kubernetes as the model for deploying our server product, we've greatly reduced the footprint of what is our application and taken effectively Kubernetes, which again is something that you can easily get support with. You probably have someone in your shop that understands it, or you can hire consultants who understand it, or you can go buy an O'Reilly book or come to a conference and learn everything you need to know about it, and made that the abstraction and the interface away from everything that you're operating on top of. So it allows us to focus our time and energy on the core product that we're actually delivering. And it allows our operators, who are many across all of these installs, as well as our own, to easily manage the pieces of the system that are best left in their hands. And finally, one of the great advantages that's happened out of this is as we've become more proficient with this tooling and separated ourselves from these different cloud environments by doing this for our server customers, we've created a scenario where we can do this ourselves in the cloud. So as I mentioned, we're currently operating our own Kubernetes deploy that we rolled it and deployed it, and probably prior to most hosted Kubernetes offerings. But because we have that clean interface and boundary, we can now move that up to an EKS or GKE, and we have then flexibility to move between cloud environments. Our initial packaging is very tied to the environment that we're running in, whereas this separates us away from that, and it probably comes as no surprise that we run a very large operation in the cloud, and having the flexibility to move between clouds or to spread that work across clouds, which we've recently done, gives us a lot of opportunities from a cost perspective, from a performance optimization perspective, that we wouldn't have had if we were directly tied into the interfaces of those cloud providers. So to recap, 4 key things that I think you want to take away as an operator or infrastructure developer that are key components of how we've been thinking about software development for a long time. Number 1, make sure that you understand your customer. Really understand what their needs are so that you can focus on building the things they need as opposed to every possible combination of what you think someone might need. Number 2, focus on your core competencies. We all have a thing that is driving us as a business and brings in either the revenue or the customers or whatever it is that you're measuring by. And every time you spend energy on something that is not that, you are using valuable time and not creating value for your organization. We never make perfect decisions, so find ways to abstract away from the technology and tools that you're choosing such that you can make changes later and be more resilient to that change. And then finally, reduce the total complexity in your system by creating layers of abstraction that take your sort of thinking and cognitive load away from the things that you shouldn't be worrying about. All right, thank you. And if you're interested in these topics, I don't know if you can see the little link at the bottom there, but we're always hiring and very interested to have people who are interested in these things. Thank you. Oh, my mic is off. We have some time for questions if anybody has any. Otherwise, thank you very much. Yes. I think there's a mic somewhere, but you could also just yell and I'll repeat it.
Do you have any, so I think this assumes everything runs on Kubernetes. Do you have any VMs that don't fit well on Kubernetes?
Yeah, so I think sorry, the question was, do we have anything that doesn't run on Kubernetes that is impacted by this? So our system is yes, very complicated, but we have sort of an unusual use case that drives our non-Kubernetes components. I guess there's probably 2 things. One, in our cloud environment, we don't deploy our primary data stores inside of Kubernetes, mostly because they've been there for a really long time, like predating all of our service infrastructure. But that's not necessarily how we deploy the server product either. So there's that, like data stores. But that's a configuration thing, basically. You can say, okay, I need access to these data stores, and they're here. So that's one. The other thing that is really key for us, but I think is an unusual case, is the raw compute, effectively, that we provide as part of the CI and CD platform to execute your jobs as one of our customers, don't run as as containers inside of Kubernetes. We have to, in some cases, they're raw VMs. In some cases, they're physical machines. And in some cases, we're composing together a set of Docker containers that represent the work that you want to do. And in all of those cases, we do that outside of Kubernetes. But I think again, I think that's very specific to what we do, because most systems that I think about aren't doing arbitrary compute for other people. That's a very sort of CI and CD specific problem. Does that answer your question? Yeah.
So your original server product, the on-prem, was it Linux only? Did you support other systems? And yes, how did you convince your customers to go Kubernetes?
Okay, so the question is, in the original system, was it Linux only, or do we support other systems? So the answer is yes. All of our services effectively run on inside of Linux containers. The compute for the purposes of builds that I was just talking about is not as constrained, but that exists outside of Kubernetes, as I was just describing. So it's always been a Linux-only operating environment. The thing that I think we get actually as a result of this change, going back to the abstraction, is we care a lot less about what maybe flavor of Linux or distribution or how you've configured your environment around that. Because actually that was another learning that we had with respect to these customers, is they might have a very specific, like, we run everything on Red Hat Enterprise, let's say, and we have an image that is locked down, and we've stripped out everything that we don't want in there. It's been hardened by our security team, and that's how we want to run. So we can go deploy Kubernetes on top of that, and then, so not we, that customer can deploy Kubernetes, and that's our interface. Whereas previously, we had to validate, that our stuff would run in any given Linux distro, versions, combination of packages that were installed, et cetera. And it's another layer of abstraction that we created for ourselves that gets us away and gives us access to broader spectrum.
But my question is, I understand the benefits that's
Mm-hmm.
part of that. I'm just asking, did you have any problems with customers not willing to go Kubernetes and saying, we have to use whatever operating system we use?
Yeah.
What did you do with those customers?
Right. So, I mean, to be clear, we're in the process of this transition right now. But we've always had to tell them they have to use something, right? No one has ever been able to just take our software and sort of run it as a binary or whatever. And that stems from the fact that it's a complex piece of software, right? And so the difference, even if you had to install it yourself and you had no one in-house, the difference is, one, us telling you, go install this thing that you don't really know anything about, and basically we're going to have to tell you how to operate it, versus this is a foundational layer. We can help you get that installed, and we run it ourselves, but you can get a lot of help in terms of sort of using that overall. It's actually been more of a pull the other way, though, if I'm totally honest, where people have said, we have Kubernetes, we've built a Kubernetes base of knowledge inside our company. We're investing in that. We're training people. We're hiring people. Please allow us to use that, because that's where our expertise is now, right? So I think again, I would say 2017 was a year where everything kind of went in the Kubernetes direction, right? Most of the other orchestration engines kind of just became wrappers around Kubernetes. And so the community and the knowledge base is big enough now that that's actually a real advantage in a product offering. Does that make sense? Yeah.
Do you think that Kubernetes is the right abstraction to hide the complexity?
So the question is, do I think that Kubernetes is the right abstraction to hide complexity? And I think you can take both views of this, right? So where I show the change in what is actually our product. I mean, Kubernetes, if you are a shop running your own cloud and you are deploying a simple application on top of an AMI or whatever, saying, oh, well, now we need Kubernetes because that's what everybody is doing, is adding a lot of complexity, right, that you may not need. And so the question is, where is the trade-off for you and your use case and your application? In our case, we got at least a consistent, like if just looking at our cloud environment as a starting point, we got a consistent way to deploy and manage containers. We were already building things effectively in containers. In a way that allowed us to easily define, these are the communication paths we need, but these, we don't care about how that exactly happens inside of the system. So we traded off some things, but we took on the burden of management of Kubernetes itself. And I think if you bring all of that in and consider that to be part of your work, then your trade-off, the point at which you trade off and get a net reduction in complexity is probably high. But when you realize that you can actually hand that off to someone else, right? If you go with an EKS or a GKE or whatever, then you have taken a lot of the complexity, which was the underlying systems, and moved it away, basically, from what's on your plate. And so your net reduction in complexity is in a much better state. And so the trade-off is, or the trade-off point would be much lower. Does that make sense?
So like, one of the takeaways for me from this KubeCon is that some companies started building abstractions on top of Kubernetes to hide the complexity from application developers. Like the keynote from Airbnb engineer and keynote yesterday from Julie Evans from Stripe, like they're just doing that. They're hiding Kubernetes behind another layer of abstraction. I was thinking if you're looking at this as well.
I want to answer your question, but do I have time to answer this question? Are we, okay. So the question was basically, is Kubernetes the right sort of level of abstraction, or should we go one level up, right? So you can imagine a world, and we did have this conversation, where we would say, well, we have two different deployment models, so let's build a definition that allows us to basically spit out versions of our configuration and everything else that work in both of those environments, right? The replicated deploy and the Kubernetes deploy. And that is totally viable, and I would almost argue that it's a good insulation even if you're just using one, right? Insulating from change. On the other hand, that we would have to make that engineering investment, and we're a pretty small engineering team. And so the ability to say, you know what, let's just pick one thing and we'll go with it for now, and then we'll back ourselves out of it when we need to, and at least make sure that we've constrained everything to a particular boundary, is good enough for us. If we were a bigger team or we had reasons to deploy in other ways, we would probably consider that. We actually thought about some other models that we had that conversation, but really the ultimate trade-off was, is this an investment that we would make right now? And I guess that's a really important thing to think about in abstractions overall. And one thing we always discuss, like abstractions are great because they protect you from these issues of change and complexity, but they're also often expensive in and of themselves, right? So this goes back to understanding your domain, understanding your customer, all of these things. You should create abstractions first in the places that have the highest rate of change. And if we can sort of commit to something for a while with Kubernetes, then we don't have to worry about that abstraction. Does that answer your question?
Yeah, absolutely.
Okay. All right, thanks again, everybody. Enjoy the rest of your day.